In the beginning, there was the point, and it was good. See, here it is. Remember. The point. Then, someone said, what if we have 2 points? One called point A, and one called point B. And we were to connect those points. Well, then we would have something known as a line segment, connecting point A and point B. Well, then somebody came along and said, hey, what if point B here was way off that page? How do I show that point B is way over there? Well, how about I put an arrowhead on it, another man said. And they said, that's a brilliant idea. Let's name that after you. What's your name, sir? Raymond, but some people call me Ray. So this is known as a ray. Has an end point, continues off, showing the arrowhead in the other direction. Then somebody came by and said, what if it went off in the other direction? Then we put another arrowhead on it. But they didn't want to give him any credit. So they just called it a line. When you have a line that stretches off in both directions, it's just a line. Not a line segment, just a line. And then someone said, what if you had 2 rays? And you put them together like this. Both of them starting from the same point. What do we call that? Well, let's call that an angle. Well, what do we call this point right here? Well, there's a special name for that point. The point where the 2 lines meet to form the angle is known as the vertex. Why? I don't know. Maybe it's some guy named Vern. That's vertex. Now, we need to be able to measure these angles. What shall we measure them in? Well, at that point, they had already been measuring temperature in degrees. So let's measure it in degrees. Does that make sense? No, but somebody said, let's do it, and they went, okay. So they said, we're going to use degrees to measure angles. And we're going to say there's 360 of them in a circle. Now we need something to measure those degrees. And along came the protractor. Because if you take 2 of those protractors and tape them together, you get a circle. You also get a pissed off math teacher there. The protractor will help you measure the degrees. Now, there's one guy that came along and said, hey, when I build houses, in order to get my wall to stay upright, I need to have a 90-degree angle. Let's call that something special. All right, let's call it a right angle because it helps things keep things upright. So it's a right angle. Then they said, well, look at this. This is a little cute little angle. It's so tiny and cute. Let's just call that the acute angle. It's so cute. Well, this one isn't cute, so let's call it ugly. The ugly angle. And they did. Until somebody politically correct came along and said, you can't do that. So they changed the name. Instead of calling it ugly, they called it something meaning sharp, not sharp, which is obtuse. See how that comes to our sharp point? This one really doesn't. Acute angles are small. Obtuse angles are big, between 90 and 180 degrees. Now, if you had a straight line, this is what's known as a straight angle. Yeah, I know. It doesn't look like much of an angle, does it? But there actually are degrees in that. There's a degree measure of 180 degrees. A straight line has a degree measure of 180 degrees. And it's also known as a straight angle. Complementary angles. Complementary angles add up to 90 degrees. Supplementary angles add up to 180 degrees. We had to do something math-wise with them. Right? Now, supplementary and complementary. Some people have trouble remembering which one's which. They have no trouble remembering that one of them adds up to 90 and one of them adds up to 180, but which one's which? Well, remember, you may receive compliments on a meal like supper, and the compliments are smaller than the meal. So the meal is the supplementary, is the bigger one, the 180. The compliments are tiny, they're the 90 degree. May work, it may not, it's up to you. Whatever you want to do with that. Now, there was a time when they were looking at these angles, they said, well, hey, you know, how do I tell the difference between these angles and these angles? Well, I could say these two angles are next to each other. That's a lot of words. What else could I say to bring them together? Well, something that means next to. Well, these two angles are adjacent angles. We know they're adjacent because they share this common vertex and one side. That makes them adjacent angles. There's one right next to the other. They do not overlap. If they overlap, they're not adjacent. Now, somebody came along and saw two lines like this, and they said, hey, it looks like this angle and this angle are the same. And it turns out they are. This A and this B are equal. Well, we have to come up with a name for that. Well, one right above the other. Let's say that they are called vertical angles because one is above the other. And that sounded like a great name until they realized those two angles are equal too. Well, turns out they still call them vertical angles. They don't have a better name for them. Opposite angles are going to be equal, and they are known as vertical angles. And with those properties, you should now be able to answer these questions. Take a moment, pause the video, give them a try. Welcome back, everybody. This one is a cute little angle, so it's called acute. This one is a straight angle. This one would require a little extra box in there to show that it is a right angle. Over here, we're told these are complementary, and this degree over here is 75. The total has to be 180, so x plus 75 has got to equal, it's got to equal 90. Complementary is 90, not 180, 90. So what do I have to do to solve from here? Well, I subtract 75 from both sides, and I get x is equal to 15 degrees. The missing angle is 15 degrees. Over here, the supplementary, which means they do add up to 180, which means that x plus 120 is equal to 180. Subtract 120 from both sides, and you get x is equal to 60 degrees. If I can draw that without messing it up. Then down here, we have two lines that cross. This one says is 50, this one is x. They are equal. X is equal to 50 degrees. What's x equal to over here? It's equal to that side. Opposite angles are going to be equal. X is going to be equal to 85. See you in class.